Alrighty, so we're still talking about derivatives, and we talked about some notation the other day or last week, whenever it was. I don't remember which lesson it was, but I put this little sign up here that I'm not able to see over there. But it has 3 of the ways that we had looked at. So for derivatives, just to look at notation real quick, it can look like f prime of x. That's one way to show a derivative. The next one on my little chart there is y prime, but I do have an x through it like this because that's not something I want you using, but it is something you would see, okay? And there's reasons for you not to want to use that one, but it does mean the same thing, okay? And why we're not necessarily using it will make a little bit of sense later. And then the third one we looked at was dy dx, but we don't really know why it's called that, right? And then I'm going to give you the fourth one, okay? So what we're doing really to get all of these, and this is like the longer way to write it, but how you show your work sometimes when you're doing things, we're going to take the derivative with respect to x, so it's just d dx instead of dy dx, of f of x. So we're taking the derivative of f of x with respect to x, and since f of x represents y, that's why that other one means the same thing, okay? But I wouldn't put dy dx of f of x. It doesn't work that way because the f of x is the y, right? And those notations will get more common and it won't be any big deal for you. I just know it's a little new right now. Okay, so who remembers what the derivative actually tells us? What is our derivative? Slope, right? So what's a fancy way to say slope? Average rate of change or rate of change, okay? But it is just slope. Like you need to, it is just slope. You have to remind yourself of that. No matter how fancy we make it sound, we could find average rate of change or we could find instantaneous rate of change. The derivative is what actually gives us the instantaneous rate of change. So it tells us the rate of change of the function at a point. And this is why I always look back at my notes before I start writing it, because I have a feeling I made it too wordy, not too wordy, but rate of change of the function at, no, it's just, I wrote good. Okay, so the rate of change of the function at a point. If it's average rate of change, I have to have 2 points, and we know how to literally find the slope like we've been doing for years. Instantaneous rate of change is when we have to have the tangent line, and we're finding the slope of that tangent line. Okay, does that make sense? So when we are interpreting them, like what does it mean, right? And we have f prime of 3 equals negative 7, okay? So our interpretation would look like something like this. The f of the function f of x, not f prime of x, but f of x, okay, is changing at a rate of negative 7 at x equals 3. Because remember, our rate of change changes because we are talking about curves. Okay, so if f prime of 3 equals negative 7, then this is my rate of change at this x value. Okay, that would be the slope of the tangent line at that x value. We okay with that? So we have found the derivative by doing the limits. We were given some derivatives, and then we're going to look at approximating it. So the derivative of function at a point, right, tells us the slope or the rate of change of the tangent line. Some of this is a little repetitive from what we wrote the other day, but there's nothing wrong with being repetitive. Tangent line to the curve at that point. Sometimes we are not able to find the exact derivative. In that case, we will approximate or estimate the derivative using a fancy word here, difference quotient. And the lines, they're not big enough for me, so they might not be big enough for you. Okay? That's the average rate of change. All that is slope. Your difference quotient, if you think about what slope is, it's the change in y over the change in x, right? You subtract the y values over you subtract the x values. So a difference quotient, difference means you subtract. Quotient means you have a fraction, or you're dividing. So that's what, like, f of b minus f of a, oh, that's an x, a over b minus a, or y2 minus y1 over x2 minus x1. That's what the difference quotient, again, is just slope. Okay? Different words, but it is the same thing. And we're approximating it because we're having to use 2 points instead of just 1. And when we did the limit, okay, and we use the difference quotient like that, the limit gave us the exact. We weren't approximating. If we're not taking the limit and we're literally just substituting in numbers, that's when we're approximating. Okay? We okay with that? All right. So here's how we can approximate or estimate the derivative values. If you are given a table of values, you're going to use 2 points and difference quotient. So this is basic slope like you learned in Algebra 1 or maybe before Algebra 1, okay? This is literally just the change in y over the change in x, but our work has to look more like that. It's going to look like it's harder than slope, but it just looks that way, okay? If I have a graph, okay, because I'm approximating here, then I'm going to calculate the slope of the tangent line. And then why we need our calculator here, if you are given the function and a calculator, then you use the derivative function on the calculator. Those are our options. Okay. We good? All right, so let's start with tables. We've got this table of values, and the function is continuous. The function is continuous and differentiable. Okay, now let's think back to what I said the other day. And we haven't really talked about how we know if it's differentiable yet. We know how to know if it's continuous or how to find that. But without them just telling us right now, if they only told me it was continuous, did that guarantee that it was differentiable? The answer to that is no. But if they only tell me it's differentiable, does that guarantee it's continuous? The answer is yes. So if it didn't say continuous and all it said was differentiable, then I would want to make sure and write continuous over this, because this guarantees that it has to be continuous in order to be differentiable at specific points. And like I said, we'll get more into that, but you want to start at least recognizing those words and knowing which ones kind of go together. Okay, so we are going to approximate f prime of 2. So we always look to see what we have, because there will be lots of times where you might have something as f prime of 2, and you look at the table, and that's actually g of x, because f of x is given somewhere else. So make sure you're paying attention. I have f, and I have x, and I want f prime of x. Okay? But I have to approximate it. I can't find it exactly. So I look, 2 would go right here, right? So I think the best thing to use to approximate, since I'm using a table and I'm just going to straight up find slope, would probably just be these 2 points. I think that's going to give me a better one than if I used the 1 and the 7. Would you agree with that? Oh, come on in. Yeah, you're fine. Just kidding. Thanks. Don't go right now. Is this say go to the counselor? I've been getting those all day. Yeah. Go journal elective. Okay, so do you understand why I would pick those 2? Because if I I want to approximate f prime of 2, and this right here is my x value. The x value falls right here. So using these two to approximate the slope makes a lot more sense than maybe using 1 and 7, even though 2 is between 1 and 7, right? Okay, so then we want to find, I want to find f prime of 2. That's going to be my difference quotient, but we're going to write out some work here, right? I'm using these 2 points, so I'm going to have f of 3 minus f of 1. That would give me my y minus y, right? I know we already know what they are off the table, but we're writing this down to show we know what we're doing, over 3 minus 1. Everybody with me? Then it's just a piece of cake. It really is this easy. F of 3 is 1 minus a negative 2 over 3 minus 1. Now, if this was the end of it, and if this was a free response question, I could totally leave it like that, right? If it's a multiple choice question, that's probably not a choice, okay? But if that way, knowing that you can't, we're always going to go ahead and go the full way just to make sure that we can add and subtract positive and negative numbers, because that's still important. But that would be a safe stop. But then if I do 1, this will be 3 over 2. So I get 3 halves. That way, if you make a because right here, I know you know how to add and subtract positive and negative integers, or you wouldn't have made it this far. Do you ever still do stupid things with signs sometimes? Yeah, because it's so easy to just do that wrong because you're zipping through it. So might as well just stop. Okay, we good? Questions? All right, so if I want to approximate f prime of 5, which two numbers, or which two x values do you think I'd use? 3 and 7. See, that's a great choice right there. All right, so f prime of 5, and then you go ahead and write it out and find that, because I think you can do that without me. Just make sure that you can get your notation in there correctly. Wait. Y'all got one? All right, we good? Now, leading up to here, like especially when you did it in Algebra 1, or even if we'd have done this last year, if you'd have stopped here or here, then I probably would have taken off some points, because you've got to know, I mean, you would be surprised probably, nobody in here, but students that get here and can't tell me that it's 1, give me 0 or something else. So we make you go up through calculus to all the way to the end, so we know you know what you're doing in the middle, but then you could stop at one of those other 2 spots on the actual exam if you wanted to. All right, we good? Just slope. Really that easy. I'll flip it over. All right. So we want okay. So we are going to have we're going to approximate with our tangent lines. So we're going to start at, and using your ID as a straight edge would probably be very helpful. Mine are not going to look very straight, but having a little thing here. So if I want g prime of negative 2, I would put this, let's see, I do have a ruler somewhere. This will probably mess up because the board's touch screen, but what happens when I put it on? Yeah, that's a hot mess. Never mind. Could have done it on my old board. All right, at negative 2, so when x is negative 2, I want to draw in a tangent line right there. So like there's my point of tangency. If you're actually using a straight edge, it probably looks like you're going right along what that is. Okay. All right, we good? So if I do that, then it looks like if I use maybe this point and this point, and we're kind of estimating, right, would say that the x value here is maybe negative 2.1, would you say? And then the y value could be like negative 1. And then here we could have negative 1.9, and then a positive 1. You agree with that? Well, you can estimate it with kind of anything. I just went with the whole numbers on the y's and just kind of a little guess at the x. Okay? So because this is estimating, right? So it's semi-guessing, which we don't always want to have to do, but it'll get us close because we're approximating. That makes sense? Okay. So then here, this is the graph of G, right? And so it says that here, right? And it also says that here. So we want to make sure that it's labeled, and if it's not, then we label it. Because again, it could be a graph of G prime or something like that. So I'm going to have G, so G prime of -2 is approximately, because we really should have done that on the other ones too, G of, we want to do -2.1, we'll do that one first, minus G of -1.9 over -2.1 minus a -1.9. And then for the other examples, we're going to skip this first step just because there's not a whole lot of room to write. So we'll finish this one right up here. What is G of -2.1? -1. So I get -1 minus 1, right, over, then what's -2.1 minus a -1.9? 0.2, positive or negative? -0.2, right? Because that would be plus a positive. So this gives me 2, -2 over -0.2. So that becomes positive, right? What is 2? How do you say this decimal right here? How do you say this one? Negative what? 2/10. Yes, -2/10. So this is negative over negative gives me a positive. So I've got 2 over 2/10. Yes? If I change flip, what does my answer end up being? 10. Because I'd multiply by 10. Oh, wait. 10 over 2 times 2. Yeah, we get 10. So that's the approximation. Now look at the actual slope. That's a pretty steep slope, right? Does 10 kind of make sense? It kind of does. You wouldn't necessarily always have to do those decimals by hand, but I think we can handle that one just fine. Yes, sir. It's going to be like, you're not going to have a whole lot of this actual estimating like this. We're doing this before we get to something else to kind of show you what's happening. Does that make sense? So we're just going to kind of struggle through this a little bit. I don't know that we need to do them all. You get the idea of this, right? So let me just pick one more. Let's draw them all in, and then we can pick one. Let's just draw in what's happening. That's really the more important part, because this is really kind of guesstimating. It's one of those things where you're told all the time, and I know I say it all the time, never guess off the graph. We never guess. We never guess. And now I'm like, okay, we're going to guess, and it just doesn't seem real right there. I know. It's not a good thing to drill into your brains. Okay, so G prime of -1. Let's at least get the tangent line on there. So at -1, this is the point right there, right? So my tangent line would look something like that. Then let's do G prime of 1. That's right there. Yes? And then I could draw that in. And then G prime of 0, when this is 0, I get, it's like right here. Okay. Could you come up with some numbers to actually estimate that? Which one would be easiest? Maybe this one, orange one, G prime of 1? Let's just go with that one. Because like I said, we're not going to do this a whole heck of a lot. We could say that, I don't know, your line probably looks better than mine. What, could you say like 0.7 and maybe 1.3 for this one? Mine doesn't look that, mine's not straight. Yours is probably closer in here. Let's do that. So let's say that this is, so my y value can be 1. That'll be easy. We'll do 0.7, 1. So we don't do 0.75. That would be fine too. But then I feel like that kind of comes out here, and we could have 1.3 comma negative 1. And then we would literally just be doing the slope. So since we're doing that, let's go ahead and, if we're not going to do all these, because I've just decided on the fly, we don't need to do them all. It's not proving anything to you. So g prime of 1, let's go ahead and do our official notation here. It's about g of 1.3 minus g of 0.7 over 1.3 minus 0.7. So g of 1.3 is negative 1 minus g of 0.7 is 1 over, what's 1.3 minus 0.7? 0.6. So this gives me negative 2 over 0.6. Could I reduce this right now? I could have reduced the other one also, right? Just didn't. I can divide them both by 2. So that's negative 1 over 0.3. So isn't this 3/10, right? So if I keep change flip, then I would get negative 10 thirds. And the slope is negative, and that's about what we got. Yes, sir. Yeah. Yes, because we are approximating it. And honestly, if it said, so if it said find the, which it wouldn't on here. I don't even like these examples. I feel like that's making things more confusing than it needs to be. On here, let's go back and fix this. If it said find the average rate of change, in your average rate of change, you just boom, straight up do this, right? But it did say find, we're going to approximate this. So this should say f prime of 2. Since we are approximating, you have the squiggly equal signs, which means approximate. But I don't put them here and here, because I'm saying it's approximately this, but then this actually equals this and this. Does that make sense? And so here, this should be squiggly also. But then these are regular because these things all being equal is a true statement. Saying that the derivative is equal to this number is not a true statement because we're approximating. Does that help? And there are times when if you don't put the squigglies, they're going to count you wrong on that. But you could be asked to approximate it using a table. You could be asked, you're not going to be asked given the graph. It's just, we just did one that way. And then we're also going to do it with a calculator. But we'll get there in just a second. So for which values of x is g prime equal to 0? So how would we know, like, what does g prime represent again? Slope. So when the slope is 0, what does it look like? All lines are straight. Horizontal line. I know what you mean. All lines are straight. Horizontal line. So I've got a horizontal line here, horizontal tangent, and a horizontal tangent here. Right? So if we are approximating, because we don't have any choice but to approximate because we don't have an equation, right? We could say that's like at what? Because you give the x values, like negative 0.8. Does that sound good? And this would be like 2. What? 2? Okay, we can do that. So we can say that x is about negative 0.8 and 2.2. It's more important right now that you know it would be a horizontal line and that you know what where it is, not you actually guessing a number. And I will tell you this, on the AP test, there was a question about it was part of a FRQ, and you had to find the derivative or find k prime or whatever it was when k prime is 0, that sort of thing. And I said, okay, so what line has a slope of 0? Well, a horizontal line. All right. Well, how do you find the slope? Well, it's the derivative. Because somebody said they got stuck on it. I asked them those 2 questions, and they're like, oh, like it was really just that simple. It's slope. It is just slope. It's derivatives. We're going to learn all kinds of derivative rules. We're just looking at all this before we get into those derivative rules, so we know what the heck's going on with the function before we learn how to actually find them differently. Okay. So now this is asking me to put them in order from least to greatest. So and you're going to look at your graph. Okay, so we have g prime of 0. G prime of 0 would be this pink one. Would you agree? G prime of negative 2 is the green one. G prime of 2 would be really close to this one. So we want it from least to greatest. So this is really, really close to 0. This is a big positive number. This is kind of a big negative number, right? Without even knowing what they are. So which one is the smallest? Negative 2, 0, or 2? The slope is positive, slope is negative, slope is really close to 0, right? So if we're going from least to greatest, we're going to go pink, red, green. You agree with that? So that's 0, 2, and negative 2. So I would have G prime of 0, G prime of 2, G prime of negative 2. Okay. We don't know what the values exactly are. We didn't even estimate all of them, and that's okay. But by looking, we understand what's happening with the slopes, and that's what we need to get right now. Okay. So then we look at, so we already know that we feel like 0 comes before 2, right? And this has a 0 and a 2. So then we got to look at 1. G prime of 1 is like my orange one. So where would it go? Would it be for, because that would give me orange. What do we have? 0, 1, and 2. We have pink, orange, and red. Is the slope steeper here or here? Think about what's happening. My graph is decreasing, right? Here's my rate of change was at 0, then it got negative, and then it's getting less negative, and then it's getting to 0. So if I'm going from least to greatest, looks like it might be pink, orange, red. Would you agree with that? Okay, so that would be 0, 1, and 2, just like it is. G prime of 0, G prime of 1, oops, and then G prime of 2. All right, so you look at C, see if you can figure that out. You can talk to each other about it. It's fine. Negative 1. It's prime. What did I do? Oh. Well, it does say G of 1. So G of 1. So let's go with what it says. Okay? Maybe it's a typo, but let's go with what it says. What is G of 1? 0. Okay, so that's 0. And then, oh, goodness gracious. Then we have negative 1 and 3. I would have just used it as prime because I wasn't looking close enough. Negative 1 does negative 1 have a positive or negative slope? Positive. And then does 1 have a positive or negative slope? Positive. No, 1 has a negative slope. Oh, I'm sorry, 3. 3 has a positive slope. Which one is steeper? Which one's a bigger number, my purple or my blue? My blue. And since they're both positive, which one of these things come first? G of 1. So we'd have G, plain old G of 1, because that's 0. Then G prime of negative 1. And then G prime of 3. Do we agree with that? Good catch on the G thing. Any of the rest of you notice that? Yeah, I didn't notice it. I'm going to be honest with you. Should we notice those things? Yes. Should I have noticed? Yes. Okay. All right, so before we do this on the calculator, we're going to have a couple settings that we need to fix on the calculator. So I want you to turn it on, and then remember, you want to, when you hit on, if it asks you if you want to hit 1 for new. If it asks you if you want to save, just say no. Then we're going to add a calculator, and then we also want to add a graph. So to do that, we do Control Doc, that adds a page, and we choose 2 for graphs. Okay? We okay with that? All right. Everybody have both of those things in there? Yours is still loading. Yeah. I think we're gonna take a day. I'm gonna maybe keep y'all's calculators and update them for you. Is it still loading? Well, even still, it just may really need to be some updates here. Okay. So 1, and then you add a calculator, and then you do Control Doc and add a graph. So is everybody here now? Yeah, absolutely. Yeah, so then we're going to hit the home button again. We're going to fix a setting here. You already have your new stuff in there. That's totally fine. Click 5 for settings. Yes. 2 for document settings. On. Well, I can't do that now, but you hit the home button. 5 for settings, 2 for document settings. Your display digits, change it to float. Yours most likely does not say float. Okay. Does it float? It says float? Okay. Oh, we don't want float 6. We want float. Just plain old float. Okay. And then your calculation mode, approximate. You hit the home button, 5 for settings, 2 for document settings. We good? The home button, the little house, 5 for settings, 2 for document settings. And then make sure this says float, which it might, if whoever had your calculator last year actually did like this. But they may not have had to do it if they were in stats, because I don't know what you do for stats. So, and then make sure calculation mode says approximate. Okay, we good? All right. So now let's do OK. And then hit 4. You should be here again. Yes? 4 for current. Get you back where you are. Okay. We on a graph? We're going to hit menu while you're looking at your graph. 9 for settings. Make sure that one says float. Yeah, just float, not float 6. And then make sure you have automatically hide plot labels checked. Okay, what? Because you're not on the graph. If it's on radians, it's fine, because we're not really going to use degrees. I'm more worried about the float and the hide plot labels right now. Do we have that much? Okay, and then you shouldn't have to do this anymore. Maybe if I update your calculators, then maybe we'll go back and check, but okay. Now, are we at a graph again? What are we stuck on? Mm-hmm. Yeah. All right, so we're back at a graph. So on this graph, that we have the example 5, h of x equals the natural log of x cubed plus 11. So we're going to graph that. Natural log, here's your e, so we do control natural log. And then it is x cubed plus 11, x cubed plus 11. You got it? There is a power button. Okay. What are we doing? Oh, do control and hit the left. You added something else. One more time. Well, you don't have a graph at all. Yeah. Okay. Do we have, now once you type it in, notice that you don't see anything, because it's not going to graph it until you hit enter. Then you graph. So if you see it, it's because you hit enter, and that's totally fine. Okay? Now, we want h prime, we don't just want h. So we are going to also graph the derivative, even though we really don't even care about the graphs right now. Doesn't matter, window, none of that matters because we're not actually doing anything with the graph except letting it help us. So now we want to put in something else. So we're going to hit tab. That makes F2 pop up, right? So I want the calculator to figure out the derivative of the function for me and graph it. So in order to do that, right next to the 9, you see this little key that's to the left of the book? So if I click on that, then these little teeny tiny things pop up. And right here, you see past the big pi, you see the D on the top, D on the bottom. There's some other ones, but they're doing other things that we don't care about right now. You're going to click on this one. And click on this one. And then that should pop up in F2. Are we there? Okay. So you want the bottom to be X, because it lets you define the variables. We're all doing, it's all X and Y right now. So D dx, like that last thing that we had there. And then it's asking you, and for this next little box, what do I want to find the derivative of? I want to find the derivative of the function above it. So I can literally type in F1, open my parentheses, put an X in it. All right? So it's going to graph the derivative of the function that we typed in. You okay with that? Then I'm going to hit enter. There you go. And don't even worry about why that happened. Just it happened. That's great. Okay? So now in F1 we have our function. In F2 we have our derivative. Yes? Everybody have that? Jaden? What are you stuck on? Okay, so you have to put an X in the bottom. And then arrow over F1 of X. And you literally just type F1 and then open your parentheses. F1, open parentheses, X, right there. And then enter. QWERTY. Okay. All right, are we there now? Everybody have these two graphs? Okay, so we have the graphs because we're concerned about the functions, not that we're not actually going to analyze the graph at all. It's kind of irrelevant to us. So now we want to go back to our calculator page. So we're going to do control and then left, and that just switches to this. Now, if you look on example 5, you want h prime of 1, right? Where does h prime live in your calculator right now? F1 or F2? F2. So I'm going to type in F2 of, because really that's h prime, yes? And I want h prime of -1. Make sure you use the negative sign, not the minus sign. And then you hit enter, and it gives you your answer. Okay? You'll get better at it. You'll get faster. And you wouldn't just be doing that. You'd be doing some other things. So go ahead and find all of those h prime values.
Is there like a button to switch between decimal fractions and the other calculator?
Yes. What is it? I don't remember. Did y'all get 0.3 or 3/10? Okay, I think that's because on here when you did 5 settings, and we want document settings, yeah, the calculation mode, that's why we were changing the calculation mode to approximate. And then you should be okay. And then we can go back to current.
Right.
Yes. 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 So, what did you get for h prime of 0? Okay, let's go back over here. Okay, so we got here, we got h prime of -1 equals 0.3, right? H prime of 0 equals 0. This asks for h, right? So I don't want F2 of 4, I want what? F1 of 4. And that one gives you a longer decimal, right? So I'm here, and I want F1 of 4, enter. And we use how many decimal places? 3, always accurate to 3, at least 3. So if you want to write more than 3, that's fine. We could say h of 4 equals 4.3. What's wrong with this? 4.3 3.174. Or 317 is fine, but you can go farther. You don't need to write out 20 of them. Maybe because I can't see. Well, you can truncate or round, so it's really okay either way. Yeah, but yes, but I couldn't see that. This is a box for some reason. And then you know how to find h prime? Yes? Okay. So because I was kind of pushing it to be able to get through the calculator part, we will start here tomorrow. We will type this in together, and we will go through that process again and make sure everybody can push the buttons. If you want to try and do this one before then, you can do that, but we'll double check our settings too. Okay? We good? All right.